Alright, so we want to do number 42 and 9.1. Says, I have some positive constant k, and t is an angle measured in radians. And I'm supposed to look at an equation for t that's k sine t equals t squared. Cool. And I'm supposed to explain why the solution to the equation must be between minus root k and root k inclusive. So, what are they saying? What's the solution to this equation look like? Like if you solve this, what are you going to get? What are you going to solve for? Yeah, you're going to solve for t, right? So when they say the solutions to the equation, they're saying t's, right? The answer is going to be between minus root k and root k. What do I need? What symbols do I need there?
Less than inclusive.
Yeah, so less than, and then because they said inclusive, I need equals, and less than or equals here. Okay, so part A is telling me this, right? And then they're asking why.
I thought because you got a square root both sides. We get plus.
Okay, so what if we hit both sides of this equation with a square root? Why do I not think this is actually going to solve things?
Because you
Still
get a
have
square
the t
root
on
sign.
one side and then the t on the other side.
Yeah, you got t's on both sides, right? So normally you'd subtract this stuff to the other side, right? And then like try to factor a t out or something. Why can't I do that here?
It's attached to the sign.
One
Yeah.
Multiply it out the sign.
Because one's having sign done to it, and the other one's just kind of plain, right? Crap. I'm not going to be able to get those things together. This is actually a really hard equation to solve. We don't have tools for this. You won't have tools for this till you get to Calc 1, halfway through the first semester. And even then, it'll just be a numerical method. So, yeah, I haven't got good tools. Let me just look at square rooting both sides. Like, it seems like that's where Kate got a square root from, right? Okay, so what do you got? You got plus or minus, what?
K sine t.
Square root of k,
Oh, okay.
square root of sine t is t, right? Okay, then what do I know about this piece here?
That's just what it looks like. You can throw it on the other side.
Yeah, I can throw it on the other side. Yeah, I'm not sure either. So when I look at this, I'm seeing one thing that I know for sure. And that's that sine of t lives between what and what?
Oh.
In other words, what's the biggest sine t ever gets and what's the smallest sine t ever gets?
Can only get to one and
Yeah.
negative one.
So this piece here, right, lives between, well, undefined, I guess. Right? But at the very least, if it's defined, it's smaller than 1.
Greater than or equal to 1. Oh, no, you can't have a negative 1 in the, okay, got it.
Yeah, I don't know how to feed a negative into the square root.
Yeah.
Which is a little weird, right? But this thing didn't actually have that square root. I put it in there. If this is negative, this thing's not going to have a solution because t is squared on the other side, so this piece is positive. K is positive. If this piece is negative, that's not going to work anyway, right? So anytime it could work, I know that that sine of t is going to be smaller than 1. And then once I square root it, what am I going to get? Yeah, something still smaller than 1, right? You guys with me on that? So this piece here, this whole chunk, is going to be smaller than or equal to 1. And so t, which is going to be equal to something smaller than 1 times plus or minus root k, is going to have to live between minus root k and root k. Guys good with that? So really, you could phrase this y as because sine of t, right? Maybe let me say, because negative 1 is smaller than sine of t is smaller than 1, right? Guys with me on that?
Okay.
And so that'll force t squared to live between minus k and k. T squared is really bigger than 0 anyway, right? So I can ditch the minus k and put a 0 in there. And then we could square root this whole equation. It's maybe actually better to do this because I'm not sure that you guys know how to square root inequalities.
I probably did at one point, I don't remember.
Yeah, I'm not sure that you did.
I was in
We-
calc already.
We don't spend a ton of time telling you guys how to solve inequalities. The key here is that the function that I'm applying to both sides goes up all the time. And so it's not going to switch that ordering.
Okay.
Cool. All right, so that's a little wishy-washy on the y, but maybe this is better. All right, so then we're supposed to approximate every solution to the equation when k is 2. Okay, so when k is 2, that thing is t squared is what?
2 sine t.
2 sine of t?
2
Okay. How do you go about approximating these? What's an option? I don't know what to think. Any thoughts?
Well, did you scale up your inequalities by 2?
I don't know what you mean. What do you mean?
Like, how it's -1.
Oh, this thing?
Yeah.
Oh, yeah.
That says it's
We could maybe use a picture. That's probably a good idea. That sounds like a little bit what you're suggesting. So I could go, okay, t squared looks like this, right? Okay, what's sine look like?
Squiggly.
Squiggly thing, right? Where's it start? 0, 0. So I think we got something like this for sine. Oh.
It's too high. Too low.
Correct. Oh, and it's too high. I see what you meant. I thought you were critiquing my picture. I'm sure that my picture's all jacked up.
Oh, English.
But at least one of these things I know right off the bat.
It's equal at 0, 0, and whatever that other thing is.
Yeah, so if I plug 0 in, right, I get 0 for t squared and sine of 0 is 0, so I get 0 equals 0. Cool. So I got one solution, right? And then the other one's tougher. What's up?
You know that online graphing calculator I emailed to you that the other day? You could totally use that on this.
Yeah,
Yeah, you could just.
we could totally use a graphing calculator for this.
Yeah, it's calculate the value, right? For-
Yeah.
Okay.
Yeah, so we could plot this function, and then we could plot that function, then we could ask the calculator to calculate the intersection. That would be totally doable. There's a couple other methods you could try. They all boil down to the same calculus method.
Since this is a in-book problem, I imagine it would be an actual set points for that intersection. Like it would be like a 3.2 or something like that versus like a 3.94 comma, like a really long decimal number. Like would that be a really simple? If you did use the calculator, my real question is,
Oh,
could you
is this going to
approximate
come
it?
out nicely?
Yeah.
My
Can you
guess is that
approximate
this
it?
probably isn't going to come out nicely, but
Okay.
that may just be that I'm standing at a whiteboard. Like,
Yeah.
there's a whiteboard blindness thing where, like, if I'm standing up here, I might not be thinking totally clearly. But my guess is that that's probably a messy number, and the way I would get it is exactly what you're describing with a calculator.
Right.
Another thing we could do is we could try, like, plugging in some rando values, right?
Yeah, when you give
Like-
an answer though, can you approximate it if it is a messy number? Or?
Yeah,
Okay.
and they ask specifically approximate every solution.
Okay.
And so we got this one. We know there's only one more. go get it out of a calculator. Cool. You have my blessing to do that. All right, so explain why why the equation has more solutions for larger values of k than it does for smaller values of k.
Ooh, ooh.
Ooh, ooh.
It's because the sine wave reaches higher and that thing goes higher too.
So I think, yeah, so as the value of k increases, right, the amplitude of this sine wave is going to increase, right? So if I think about, all right, I got all the rest of this stuff. If I make all of that stuff taller, it's going to hit this thing more. You guys with me on that? Oh, I mean, this thing continues up here, right?
Yeah.
Oh, I get, yeah.
And
it's
then you're
the
just gonna
rest
hit
of
it
the
at a bigger
structure.
spot.
Yeah, so this one's going to eventually hit.
Oh,
Because I'm leaving that one fixed, right? The parabola is going to stay. But this other thing, like, think about grabbing that amplitude and pulling. Like, it's going to take a while for this to hit,
Yeah.
but you'll hit it eventually. It's going to take even longer for this one to hit, but you'll hit it eventually. And every time you get a hit over here, you'll probably pick up one on the other side. Cool?
Yeah.
All right, and then our last question here is approximate the least value of k, if any, for which the equation has a negative solution. Oh, that is a pain in the ass.
Wait, so it's asking
We could
about
guess.
the other side?
Yeah, so it wants to know what the least value of k, so this has a negative solution is. So when is this? Well, it's not going to actually be there, right? It's going to be like one of these that hits first as I stretch. You guys see that? But they want me to approximate. So I'm going to be lazy and I'm just going to say, well, it's over here, right? But I'm just going to use this one instead. So where's that happening?
Negative.
3 pi.
Negative 3 pi over 2.
Negative 3 pi.
Negative 3 pi over 2. You guys sure?
No, we're not.
Now you're not. Yeah, good, cool. Right, because this should be negative 2 pi.
Yeah.
Right, and then you went up one interesting tick from there, and we hadn't modified the sign at all. So interesting ticks are pi over 2s. Okay, so I'm just going to use that. So where's this dot on my, oh, I'm still using the graph from B. Let me change that to a k and a minus k. So where's that dot at then? That dot's at minus 3 pi over 2 in the x, right?
And then
On 2,
And k, or 2, right? Well, so if I think about this one, right, the thing I'm actually trying to compute, I need a k there. Okay. And then what are you trying to hit? What do you think that's going to hit? You're going to scale it up, right? You guys see that?
Yeah.
So that hit's going to happen. Let me put down the picture a little bit. Okay, so I'm going to make my parabola blue here just for illustrative purposes. Okay, so I got my blue parabola, right? And then I'm going to stretch this thing out. When I stretch that out, does where this peak is move side to side?
no, it's up and
Just
down.
straight
No,
up.
it just moves up and down, right? So where would this point be?
Negative 3 pi over 2.
Okay.
And then however many k's out.
So yeah, that'd be kind of k up when I'm thinking about it hitting, right? But it's on the blue, right? It's on the parabola.
So you could plug square root of 3 into t squared, right?
So you could plug what into t squared?
Negative 3 pi over 2 into t squared.
Perfect, right? It's a point on a graph. So it's a x comma f of x pair. In this case, the f of x I'm talking about is t squared, right? So here's the x coordinate. the y should be that thing squared. I'm going to get 9 pi squared over 4 out of that. And I'm wondering, when does this hit, right? So what does it mean for this dot and that dot to be the same?
Where the functions put out the same thing.
Yeah, when the functions put out the same thing. So that's when k, right, is, and I should be totally careful. This is a shit approximation.
T squared over.
Yeah, so 9 pi squared over 4. You guys with me on that? And I know that's a shitty approximation because I think this is definitely going to bump first. You guys see that?
Is that the answer they gave you?
I have no idea what they said.
I'm curious to see how they would do it.
Gave you an answer for it, so that could.
Oh, perfect. It's an even.
It's what?
21.
It's an even
it's
number.
even.
so
Yeah.
Oh,
that's
okay.
it.
This is 21.
No, that's 22.2. 21 will be the first time it hits.
This is the
First
answer.
integer time it hits.
Close enough.
Yeah, I don't care. I was just wondering how they did it. I like that break.
My guess is that they wanted you to do exactly this.
Well, they should say so then.
Well, they did. Does that approximate the least value of k, if any, for which the equation has a non-negative solution, or has a negative solution? Yeah, that's totally how I would do that.
It's
What's
not
that for?
tangential, so when it hits, it hits twice.
And it's not 10. Oh, yeah. Yeah, that's also true. So as you stretch this thing, it's probably going to bump twice.
Oh, yeah. I see.
Yeah. So I'm not getting the other one, right? Whatever. Cool.
As long as it's not on a test.
Lagrange multipliers.
Okay, cool. I got that one.
Yeah, that's Calc 3.
Okay.
You could get a more robust approximation using Calc 1, but it wouldn't be easy at all. Yeah, I would start with Lagrange multipliers as an inspiration at least. You can do this one with Calc 1 techniques, but you need a Calc 3 idea to start applying the Calc 1 techniques. It's gonna be a mess. Cool?
Case in point.
Yeah.